This is the first CUDAN Open Lab seminar since the sort of end of the CUDAN Era Chair project, which was a 2.5 million euro European Commission funded project to do cultural data analytics, to bring together like a broad spectrum of disciplines from cultural history. Mila is looking at us in the audience, and social physics and machine learning at the other end, I guess, and everything in between. And we are now in a sort of transition phase. So we have gone through audit and evaluation, which with the European Commission, everybody who has ever done this knows what that entails. That's how I spent my last 2 months. And basically, we are now sort of like distributed across Tallinn University and beyond. But we are funded for another 3 years to keep this Open Lab seminar series going, and basically have the shared lab and infrastructure while people sort of work in different areas. And sort of like we want to continue mixing people in this area, not only in Tallinn, but also globally. And for those who see this for the first time, we have done a cultural data analytics conference in December 2023. And this conference brought together people from 31 countries. And the special thing about this is that digital humanities basically stop short of doing multidisciplinary science, sort of similar to computational humanities, which does multidisciplinary science, but has a heavy focus on text and literature. And I'm not saying they're not doing art, audio, visual, music, fashion, food, and so on. But this is sort of something which our conference had like 2/3 of the contribution, while the computational humanities conference that happened a week earlier had sort of like 5%. And so there's really a need for sort of doing something. And here I take a word from a paper that Carl Bergstrom actually co-authored a while ago, which is about the stewardship of global collective behavior. And this paper calls for a transdisciplinary approach, which is a quite interesting thing, because what we have done the last 4 or 5 years is multidisciplinary collaboration. So people from different disciplines come together, work together, and then sort of like acquire sort of like, you know, the necessary essential stuff from other disciplines. But transdisciplinary really means you do this in personal union and togetherness. Basically, you have no excuse being a scientist, not having your humanities stuff together, and having your humanities stuff together, you have no excuse not also learn about at least computation and quantification. And that is sort of something that is our general goal. Obviously, we're heavily underfunded relative to systems biology and medicine in this regard, right? I mean, the endowment and funding for certain systems biology and genetics institutions has 9 numbers, while in our case, having a 7-number funding for 5 years is sort of something that is really extraordinary and sort of like attracts people from Australia and Dallas to move to Tallinn. And so this is sort of something that we try to sort of further nurture. And in order to basically have a sort of like good start into this new phase of another 3 years, the people who sort of applied for this inter-school funding within Tallinn University, which is in this room, Mikael Tamm from the School of Digital Technology, Andres Karius from representing the School of Humanities here in Tallinn University, and myself representing the School Baltic Film Media and Art School. Sort of we have come together and decided, like, let's do the Open Lab seminar in the same way we have done in the last 5 years. You may not have known this, but basically what we did is like we asked the team members to come up with speakers and everybody got a shot. So nobody sort of like, you know, sort of governed over other people and had like sort of 2/3 of the talk invitations, but quite the contrary, we tried to sort of have a balanced spectrum of people from across disciplines, from across subject domains, and actually genders and geographical coverage, because we think that this sort of like not only helps us to learn over all these different areas, but the definition of what cultural data analytics, cultural analysis, cultural science, whatever you want to call this, actually emerges from the sort of like choir of voices. And because we're in this interim phase, Mike and I, who are co-organizing this Open Lab seminar in the next couple of years, we thought, let's start with 5 keynotes that we select, which we think cover the spectrum sort of in a really exemplary manner. So we're very, very, very sort of happy and grateful that today we have Jevin D and Kati Bergstrom with you both. Both of you are sort of like, I think it's not too much to say, fundamental voices in sort of like fighting academic bullshit. I can say this word right now because you have a course and a book which is called that way. And one of the interesting things is that's not your only thing. Carl wrote one of the now 2nd edition most prominent textbooks on evolution. And Jevin is actually one of the driving forces behind the Center for an Informed Public at Washington University in Seattle, which has become ever more important in the last 10 days. Probably the last person realized that this was important. And so basically, this is sort of something which probably cannot be debated away or like is not sort of like irrelevant as you talk about bullshit and visualizations. And one other thing which I personally find really amazing is that as a member of the audience, Carl is sort of one of the leading birders in the world, and you have left the old platform and you changed to Bluesky, like 3 million people last week, I think, and you do that too. And there too, I think you are a great role model for people who sort of like get stuck with too much work and not focusing on the good stuff too. That is sort of something that is really important, not only for you, but also for many, many other people. And for Jevin, there's something similar. We had a little project going on where we sort of like tried to combine machine learning and overviews over large numbers of images with art history, looking at chroma in a project that was very much sort of a startup project, which has become sort of important for what I did afterwards. And that was incredibly fun. So with the greatest pleasure, the stage is yours for the next 2 hours. And we're very happy to discuss with you whatever you have to say, because we are pretty sure it will be awesome.
Wonderful. Let me thank you so much for that tremendously generous introduction. I'm just fighting with Zoom here to share my screen.
And while you fight with Zoom, I just want to say thanks as well, Max. Every time we get together, I'm always wishing we had more time at the coffee shop or at the conference hall between talks. I mean, you are one of those individuals that just can speak across disciplines as fastly as anyone I know. So I do want to also say that, well, maybe I'll wait till the slides get up. I'm hoping Carl and I go syncing back and forth, sometimes drop off.
Let's see, Jevin, can you see them now?
I can see them beautifully, yeah. So
okay.
That's perfect.
Okay, great.
Yeah. So actually, I'll let the slides speak for themselves, and then we'll open it up. The one thing I say is Carl and I will have to leave just a little bit early before that 2 hours, because we give a lecture to our class. This is our quarter that we teach our course, which we very, very much enjoy, and we have to be on campus for that one. So we'll have to leave just a little bit before the 2 hour mark so we can get there in time. All right, Carl, you want to get us started? There should be a slide I threw in there that
absolutely. Well, let's see. We will see what's here. Okay, let's go ahead and start. So we're talking about numbers, statistics, and algorithms, seeing through the bullshit. Oh,
it isn't there. So a lot of those new slides aren't there. So
okay.
Can I share the slides? I'm gonna
Why don't you share the slides, Jevin? I'll stop the share.
Yeah, it didn't sync. That's too bad. Okay, I have the slides here.
You know what? I think it's weird because it said the timestamp was 6:54, but we'll just let you do it.
Weird. Okay. All right. Well, still working through this post-pandemic, Max here. Okay. All right. So I wanted to start with one of our most exciting tweets that we ever got in the pre-Musk world when we were on Twitter and doing things. We received this post from at that time the president. I think we can say it that way, or maybe I should know this better, but the Estonian president at the time had been following us. Yes, And we were very excited. In fact, as you can see, we were excited publicly. Carl and I were very excited. We talked about it on Slack at that time that, wow, we're getting noticed now. And this was the person. So I just wanted to say thank you. This is a moment to come back to Estonia. And thank you for that. So
That's
now,
awesome, Jevin.
Carl, I'll let you go. All right.
Okay, I will.
So now it's yeah. So if you want to,
I'll just go ahead. I'll just go ahead and share mine. Okay.
And then I have some slides right after your first section that'll new, and I'll go back to
Fantastic. Okay. All right. So I'm going to share mine. That is great, Jevin. Let's see. Here we are. Okay. So yeah, we should just introduce ourselves very, very briefly, though we don't need to because we just had a marvelous introduction from Max. I'm a biologist by training and have been very interested for my entire career on how information moves through networks and in various ways, and that involves animal communication, the way that science operates, and then more recently the way that misinformation and disinformation spread across computer networks and other kinds of networks. Jevin, you wanted to say one or two words?
Yeah, so Carl and I've had the pleasure of working with Carl for many years, over probably the last multiple decades. And I spend most of my time, I do also think about information. I'm in an information school where that's our central subject of study. I spend a lot of my time on the education side, developing data science curriculum, and on the research side, I spend a lot of time thinking about the ways in which rumors spread online, but also the ways in which machine learning can inform and also disinform the ways, the decisions that we make in society. And I would sort of classify myself more as a computational social scientist now because of the work that I do also in what people call the science of science. And when I sort of combine those two, that's probably the area that I do most now is studying misinformation in and about science. We'll talk a little bit about that today, but probably not as much in depth as we could in another lecture. All right, Carl, take it away.
Okay, so I think in order to understand our relationship to information and to misinformation, disinformation, and digital information, quantitative information, it really helps to take a step back, think as a biologist about who we are. And we as a species are these highly intelligent, highly social, ecological generalists. We make a living doing all kinds of different things in the world, not just filtering krill through our baleen or banging our heads against a tree to pull out grubs, but we have a seemingly infinite number of ways to extract what we want from our environment. And in order to do that, we have to be what I call information foragers. We have to forage not only for food, just by getting one particular kind of food, but we forage for information so that we can learn about the world around us, so that we can figure out what are the opportunities in our environment. And those opportunities may be with respect to, maybe be physical, with respect to food, with respect to shelter, things like that. They may be social opportunities to change our social standing in ways that we desire. And we do this foraging individually by trial and error, by observation, by creating hypotheses in our minds and testing them and seeing what happens. But we also do it collectively by talking, by teaching, by gossiping, by exchanging information in a broad variety of ways. We evolved to do all those things, just as other many animals evolved to be, forage for berries or whatever. We evolved to forage for information, and in general, we do that very well. And we're a lot like this crow in a way that this is a crow at here in Seattle, and what this crow has figured out to do, it's also an ecological generalist. Instead of doing just one thing, it's very smart. It takes advantage of the structures in its environment, and what it's doing here is this is a mussel shell. And there's a mussel bed about 400 meters away, and the crow will go to the mussel bed and it'll pull open a mussel, and it can't crack the mussels open very easily. Sometimes it tries dropping them, but then the other birds will take it. So what this crow does is picks it up, flies with the mussel for 400 meters, and jams it in this crack in this L bracket here, and that holds it just right. It fits perfectly, and then the crow can peck the muscle open and eat the meat inside. And this is a remarkable behavior because this crow had to be thinking about its entire environment, had to be thinking about how to use something in one that can be acquired in one place, how to take that to another place where there's a tool. And by learning about its world and by having this incessant curiosity about this world, which if you've observed crows, they have this incessant curiosity, it's able to extract resources from its environment in new ways. And so crows do it, we do it. And if we think about, okay, so we're information foragers, what does that tell us about us and about the world we've created and the world we live in? And the first thing it tells us is that, well, if we're information foragers, we must crave information, because think about it. How does natural selection, get us to do things that improve our reproductive fitness? It makes them feel good, right? So eating when you're hungry, drinking when you're thirsty, finding shelter when you're cold, having sex more or less whenever. Those things feel good, and the same. There are these reward systems that we evolved to have for the things that improve our fitness. And because we're information foragers, we expect that we would have reward systems associated with information, and of course we do. And when we mostly the dopamine system, but when you discover something that you find something surprising or exciting, that's interesting, that catches your attention, you get this little rush. When you have created some hypothesis in your head about what's going to happen, and then it turns out to be confirmed, you get this little rush. So we have a reward system associated from information. But there could be too much of a good thing. So we're kind of used to thinking about this. We are a species that has found ways to take control over our environments. We're able to build a world around us that is a world of plenty, where all of the things that we evolved to desire, we've been able to provide for ourselves in excess. So we can create the shelter we want. We can create the medicines to keep us safe from disease. We can create food supplies. All of these things. We can create social opportunities. And so now we swim in a sea of information. We evolved to become information foragers. We evolved to desire information. Now we swim in it. I'm speaking into a machine that's, of course, most powerful information pipeline that the world has ever seen. Most of the information that we encounter these days is digital. An awful lot of it, as we're changing the way that we think and argue and explain and explore, is quantitative, is data driven. That's things we're going to talk about today. And unfortunately, an awful lot of it is also nonsense or bullshit. And we'll talk about that a fair bit as well. The thing is, having this fire hose of information right up in front of us. Then we also have cell phones. When we can't manage to be sitting in front of our television, we can pick up our cell phone or our television, our computer. We can pick up our cell phone and have it in a smaller scale. So you can do it on the bus or as you're walking down the street or whatever. We made it this way on purpose. This is what we evolved to want. We evolved to want access to all of this information. And the thing is, there can be too much of a good thing. This is like what happened to us when we figured out how to take control of our food environment. We developed industrial scale agriculture and the economic systems that were necessary to provide us with an endless variety and endless supply of the kinds of foods that were in very high demand, say several thousand years ago. High calorie, high fat, sugary or salty foods. So then we create snack food aisles, and now we're sort of poisoning ourselves on those. And this is essentially, we're doing something very similar with information. Now we evolved to want it. We evolved to want certain kinds of it, and now we're too much of a good thing. We're poisoning ourselves with information, junk food. Mismatches arise between the way that, and part of the reason we're poisoning ourselves this way is because there are these mismatches between the information that we evolved to desire and the environment in which we evolved to desire information and the environment we live in now. So we evolved to forage for information, and we have these heuristics that we use that work very well in what I'd call naturalistic environments. These might be, out in a forest or in a savanna or somewhere like that, where you're trying to learn about the animals there, the plants, the various threats. They might also be in a small society where you live in a village of a few hundred people. At most, you sort of know who's who. The information comes through these more natural channels. Our heuristics for how we learn and process information and what we think about work quite well in those settings. But right now we spend most of our time foraging in these complex digital environments, online, for example, and worse yet, these environments have been explicitly designed to exploit our foraging heuristics. So the structure of internet platforms have been explicitly designed based on enormous amounts of information about our behavior on those platforms, in order to keep us engaged, in order to keep us clicking, in order to keep us foraging, because that's, of course, selling ads, the way through, the way in which the sort of entire internet is monetized. And so the information itself and its delivery systems and the user experience, the user interface are all tailored to keep us locked in and keep us foraging and so forth. Important to notice that the sort of behavior that we do when we're information foraging has changed dramatically in the sort of more recent digital internet era. The balance of searching versus sorting depends on the frequency of opportunity. So in a world where information is scarce, so rich and thorough information is valuable. We're going to be sort of continually looking for we want to find these deep, rich sources that we can dive into and engage with. In a world of hyperabundance, where there is more information than we can possibly process, this really deep, rich information is not as valuable as things that we can consume quicker. And our online lives now are characterized by multitasking, interruption, and distraction, sort of continuous multitasking, interruption, and distraction. By design, essentially, we have these applications that are designed to push messages at us, to Bing, to whatever, to pull our attention away from whatever we're doing to whatever else we're doing. And so we're constantly trying to filter, even when we are trying to, ostensibly trying to work, we're simultaneously trying to filter a set of distractions that are coming in from through these platforms. And information is being crafted, again, because a lot of the way the internet is monetized is by monetizing this attention through ads and so forth. The information is being crafted in order to grab our attention and shaped in ways that'll try to pull us away from whatever we're doing and thinking about. And so we end up online, we end up spending more time, much more time filtering among information sources and much less time processing the information that we do have, compared to the way things were, say, when I was first a graduate student, right around the very first days of the internet, or the very first days of the World Wide Web. Sorry. And the key is we do this filtering, we don't necessarily make very good filtering choices. So we often end up looking at information that's not very useful, that's sort of distracting and beside the point, or simply wrong. And then finally, information. We talked about how we forage for information individually, but we also forage collectively, and the entire use of the internet is an act of collective information foraging, right? It's a new way of sharing that information and learning from each other and so forth. And the individual foraging decisions that we make to find information and to share information then have these collective consequences. So of course, we're very successful as a species because we learn from one another. This is an enormous part of why humans are able to do all the things that they can do. But we can also lead each other in mistaken directions, right? When we get things wrong, you can get these information cascades that pull very large numbers of people in wrong directions. And that kind of dynamic can transform a society. And we've of course seen that happen here in the United States, and it's happening around the world. So let's see, there's a little stopover point, I think, to that, where I take a breath and maybe hand it off to you, Jevin. Do you want to take over? I think you're muted, Jevin.
Sorry. All right, I'm just pulling my slides up now. Perfect. Okay.
I don't think I have any similarly long riffs later. So Jevin, we can just stick with your slides from here on out, and I can just say next when I come back on.
Sounds great. All right, so building off of what Carl talked about, this hopefully sets us up for thinking about the ways in which we can be especially susceptible to the different forms of misinformation. And one form of misinformation that Carl and I focus a lot of our attention on is misinformation that comes wrapped in data, statistics, and algorithms. So this is the central part of what we want to talk about today and what we talk about most of the time. Now, that doesn't mean that we couldn't give, 500 other lectures like many of us in this room on the misinformation that travels in other forms. And we'll talk a little bit about how it's traveling through maybe generative AI and other forms of synthetically created content. We can talk about the different ways in which it happens, especially it's especially challenging during times like elections and crisis situations. But let's focus now on the ways in which misinformation through data. And this, we're going to just kind of dabble a little bit in a few things that we talk about in our class and in the book. And those areas are we talk about the foundations in data reasoning. So in thinking about these kinds of problems, there's this schematic that we use a lot when we talk to our students about focusing in on the data input or the data output, and not so much focused on necessarily the statistical procedures or the algorithm that might be steering the results in whatever scenario we're talking about. And that if by doing that, you can actually call out the quantitative BS quite often. And you almost don't even need to look into that black box. And then we'll talk about one of the more common ways in which you can call BS on some of this stuff. So selection bias. We'll talk about some correlation causation and some data visualization. So that's kind of where we're going. But I just want to kind of really drill down or sort of hit on the head as hard as I can this idea that we're really good at spotting verbal BS, but maybe it's much harder, and we're not as good when numbers are involved. They're a lot harder because they appear replicable. They appear like they come from science. They almost appear like they come straight from heaven. They feel technical, arcane, scary to many people, even for many people in research and in science. They seem to just come straight from nature. They have this they become central to how we reason, how we communicate. You see this all over social media. You see it in business meetings. We see it in all our science meetings. And by putting that graphic up or that statistic, immediately you carry authority, and the numbers with it carry that authority. And we want people to have confidence in being able to call BS on that as well. And because they're reluctant to challenge numbers. And that's the place that we really want to focus on. And so the thing here is that this is a big problem because numbers are every bit as subjective as words, and we'll give some examples to drive that in. And I'm sure other people have examples about that well. And they're used to make us sort of feel a little bit helpless. When we're helpless, that's kind of what sort of motivated a lot of what we were doing when we were putting together the book, was to try to empower people with any background to be able to do that. So numbers do carry this power. And we recognize that even at universities, we just weren't doing a great job of teaching our students to question those numbers. So that's the motivation behind a lot of
this is so important. Yeah, if you just say the thing about questioning numbers, right? Especially because the whole thing about the humanities is we teach students to think and question. And you present students with ideas, they break down arguments, they reframe arguments, they synthesize arguments. in the sciences and in mathematics, we basically are teaching them how to carry out procedures. And we're not teaching, how do you run a gel? How do you write code for this? How do you solve this math problem? And we are not teaching them to think in the sort of critical and constructive and synthetic ways that we see in the humanities. And we think that you fundamentally need a change in undergraduate education, in science and in mathematics around that. Sorry, Jevin.
No, that's good. Okay, and why don't you take this first one? I'll take the next example.
Oh, okay. So right. So one of the key things, right, is that go back one slide for a second. Was I didn't read that one out. So one of the key things, the sort of most simple things, like when you present numbers, you've got to explain numbers in context. Just putting a number up on the screen doesn't do any good. You have to allow people to make comparisons. And so next slide. So here's the NBC News. Saying that preventing the next pandemic is going to cost, and then it's sort of shock and awe by number of zeros, a bunch of twos followed by an awful lot of zeros a year, scientists say, and that is such a bad way to present information. First of all, you could just say $22 billion. That would be a lot easier. People know what that means. They have some context for what $1 billion is. They know it'll cost half as much as Elon Musk wasted on Twitter. That's a much smaller. It's a context-rich number. With all those zeros, you have no idea what this even means. Next slide. But $22.2 billion a year, let's put it into context. So we want to make comparisons. Instead of saying, oh my God, that's so much money. Think, well, the coronavirus pandemic was supposedly going to cost the US economy about $8 trillion. So putting that into context, you could spend $22 billion a year for centuries and come out ahead if you stop just one pandemic. Next slide. The US federal budget is $4.8 trillion, or was for 2020. So it would have cost less than 0.5% of the US budget to prevent the next COVID pandemic, according to this study. Next slide. Suppose the US paid the whole bill for the world. There are 330 million people in the US, $67 per person. I don't know anyone who wouldn't have very happily paid $67 to avoid the COVID pandemic. These are ways of putting a number in context. Instead of just two twos and then the scary series of zeros, you got to put things into context. Otherwise, numbers are just being used to push people around and say, I've got the numbers, and here's this sort of, quantitative shock and awe and so forth. Okay, Jevin.
Right, and they should be presented in context, and that means they have to make fair comparisons. Now, the fair comparisons comparisons in general, maybe not fair comparisons, are used a lot to push different kinds of messages and different kinds of viral content. And one piece of viral content that goes around often are things that look like this. So they'll do a comparison. They'll say, look at the real estate owned by Amazon is greater than the surface of the actual Amazon rainforest. They're doing the comparison here. Great, right? Okay, they're playing the rules. But of course, if you look into this a little closer, we live in the state of Washington, and I can tell you that the Amazon warehouses are not taking that amount of Washington. And even if it did take that much of Washington, that certainly doesn't even come close to as big as the Amazon rainforest, as we all know. So when looking for fair comparisons, be on the lookout for comparisons that seemingly are fair, but are...
The Amazon rainforest is bigger than the entire Western United States, for example. So it's a tremendously misleading graphic.
Yeah, so it's completely misleading. So when those fair things go up, we got.
But again, these numbers give you this sense of false precision, right? You have these, they're written out to all these decimal places, and so you think, oh gosh, these people must have looked it up, and anyway.
Right, so we have built all sorts of different education tools. So we just wanted to show you one of many that we've had a lot of fun with to stress these fair comparisons and the tools on which you can do that. And I know there's many people in this room that use some of these tools, but I just wanted to just have a little bit of fun and show you one of the videos here. So let me just pull this up now. Just give us 1 second. Okay, here we go. Now I just got to share this. Sorry for the sharing back and forth so quickly or so much. Share sound and share video. Carl, can you see that? Carl, can you see that? Oh, you can see it. Okay, here we go.
Can do is try to develop skills for spotting bullshit. And one of the more effective tools out there is something called Fermi estimation. This was inspired by a physicist named Fermi who was really good at doing calculations on the back of a napkin. And his trick was to just spend time thinking about the powers of 10. So just estimating in these powers of 10, and in doing so could come to calculations really quickly.
So let's give you an example. Representative Mo Brooks suggested that the sea level rise might not have anything to do with melting ice caps. It might be because the cliffs of Dover were eroding.
The waves crashing against the shorelines, and time again, you're having the cliffs crash into the sea. All of that displaces water, which forces it to rise, does it not?
Let's try out Fermi estimation with this problem.
To the nearest power of 10, the White Cliffs of Dover are about 10 kilometers long, about 100 meters high. Let's suppose an entire kilometer fell into the ocean. That's 1 billion cubic meters fallen into the ocean. So how much would 1 billion cubic meters raise the ocean?
So there's about 360 trillion square meters of water.
Well, you dump 1 billion cubic meters into 360 trillion square meters. That raises you up about 0.000003 meters. That is 3 micrometers. A human hair is about 100 micrometers. So if the cliffs of Dover and 30 other cliffs like it collapsed today, that would raise the oceans by a hair.
So what you're saying, Carl, is that you would raise the ocean.
Thank you, Jevin. I really needed that.
All right. So these are the kinds of tools that we've been trying to develop. And I'm sure some of you, I've actually, been impressed over the years of all the new tools coming out, doing that as well. Just sorry, I'm stopping sharing here. Here we go back to the slide presentation. Share. There we go. Share. Okay. So this is one of many tools that we can use to try to force a fair comparison. And so, as we've already talked about, we have this course we're actually teaching here shortly after this lecture to students. Today, we're going to be talking about susceptibility of science, which Max had mentioned, and we'll talk a little bit about that, how even the institution of science can be susceptible to the spread of misinformation, and there are various things that we probably should do within the institution of science to improve that. So we might get into that. And this course is being taught in a lot of different places, been translated in lots of different books, and it's been a lot of fun. So now let's go ahead and talk specifically about this thing that we call bullshit. Since we've been thinking a lot about it, and if everyone's seen bullshit in their lives, let's see if we can nail down a definition. So Carl's going to give an explanation.
Yeah, so we spent a lot of time thinking, and when we taught the course and wrote the book, we spent a lot of time thinking about what bullshit was, and of course there was this philosophy first, essay, and then later monograph by Harry Frankfurt that tried to look at bullshit and its role in society, what it is, and motivated by Frankfurt, inspired by Frankfurt, we came up with the following. Frankfurt's definition would be something similar to this, right? Bullshit involves language intended to impress, overwhelm, or persuade, presented with a blatant disregard for truth, logical coherence, or what information is actually being conveyed. So you're trying to just make a certain impression on somebody, and you don't actually care whether you're providing them with something useful or not. Next, Jevin. And I think there's a fantastic illustration. I was reading a biography of Sigmund Freud, and within that biography was a letter that he wrote to his fiancée, and he says, "So, I gave my lecture yesterday. Despite a lack of preparation, I spoke quite well and without hesitation." Next slide. "Which I ascribed to the cocaine I'd taken beforehand." That's not the bullshit part. Next slide. "I told about my discoveries in brain anatomy, all very difficult things that the audience certainly didn't understand." Next slide. "But all that matters is that they get the impression that I understand it." Next slide. He was intending to impress, overwhelm, or persuade, and he was doing it with a blatant disregard for what he was actually conveying. He knew they didn't understand any of it. All that mattered was that he impressed them. That is my definition of bullshit. Now, bullshit, of course, is evolving and changing, and one of the things that Jevin and I have really concentrated on and focused on in our book and in a lot of our work is thinking about the ways that as we move to a world where data-driven reasoning is more important, the ways that bullshit has kept up. And so our definition is that bullshit involves language, statistical figures, data graphics, and other forms of presentation that are intended to impress, overwhelm, or persuade. Again, presented with this blatant disregard for truth, et cetera. Jevin, you want to?
Yeah, so I mean, here's an oldie but goodie. It's one of these kinds of presentations that you see on social media that spreads virally. And if you, of course, dig into it, it's not hard to call out, even for those that aren't practiced bullshit practitioner or bullshit caller practitioners. But this is, according to this particular social media post, it was the only chart that you needed to know of when it comes to global warming. And it actually pulled from real data from NASA. The thing is, with this particular data set, they're zoomed out so far, of course, that you can even make, you know, a diagonal line look horizontal. And it's these kinds of tricks that invoke a kind of perception of what that data is trying to tell. And if you replot this, like Philip Bump did from the Washington Post, you do see this 2-degree increase over the last half century. And then we can have a debate on what the data is really saying. But with presentations like this, this is just as much bullshit as any sort of you know, rhetoric in language that we see all the time. Now, another form of bullshit that we see quite a bit is something that we call mathiness. And actually, Carl, do you want to give this one?
Or I can talk about the VMMC. So this is a Virginia Mason Medical Center quality equation. This gets taught everywhere in sort of health management courses, and it says that the quality of service that a healthcare system provides is the appropriateness times the outcome plus the service divided by the waste. So this is sort of a standard management equation. And I argue that this is complete or nearly complete bullshit. Why? Next slide. Well, it's not clear. I mean, it's pretty clear that, you know, appropriateness is good, good outcomes are good, service is good, waste is bad. But it's not clear why they are given the particular numerical form that they have in the VMMC equation. Why, for example, do we not write instead quality equals service times outcome plus appropriateness divided by waste? Or, next slide, why not outcome plus appropriateness plus outcome times service minus waste? Or even, next slide, outcome to the appropriateness to the power of outcome plus service to the power of outcome to the waste root, right? I mean, any of these would have the same relationship, qualitative relationship with each of these key variables that go in. Next slide. And what they're really saying with this equation is simply that appropriateness, outcomes, and service are good, waste is bad. But in order to do that, they are trading on this sort of sense of rigor and importance that we ascribe to equations in a way that isn't merited, because they don't have an explanation for why they're using one functional form instead of another. Next slide. And moreover, when we use equations, we know that we know about dimensional analysis, right? When you use equations, you have to the units on the left have to equal the units on the right. When you add quantities, they have to be in the same units. So what are the units? What units are outcomes and service in that make them addable? It has to be the same units there. Quantity then has the units of next slide, I think. Yeah, the units outcome service has to, yeah, and the quantity has to be in the units of appropriateness divided by waste times whatever the units of outcome and service are. What are those units? What does that mean? And of course, it doesn't mean anything, because this is just a made-up bullshit equation that's supposed to make you think that someone has done a careful mathematical analysis of things and you can sort of plug in numbers, when all they really mean is good service is good, waste is bad. Next slide.
Sort of algebraic shock and awe, right?
Yeah, and so we see this over and over again, right? So there's you know, particularly in management, here's the trust equation: credibility plus reliability plus authenticity, divided by perception of self-interest is trust. I mean, if I flip a coin, the coin doesn't have any self-interest, so I should have 100% trust in it, right? As it goes to infinite trust in a coin that I flip. It doesn't make any sense. Next slide. Here's the Blue Monday formula. This goes around every year, which is supposedly the most depressing day in the year. This gets put out there. And so many things wrong with this, you know, in addition, you know, particularly we only raise, it doesn't make sense to raise things to powers that are that have units when you do dimensional analysis. So, but we're raising things to the powers of time and to the power of deadlines, which is of course utter nonsense. Next slide. And we saw this during COVID, when Boris Johnson put up the COVID alert level formula, which was the rate of infection, R naught, plus the number of infections. It made no sense. R naught was somewhere between 1 and 5, and then the number of infections was in the tens of thousands. So why the hell would you possibly add those together? It didn't make any sense. What he really meant is that if the higher R is and the more infections, the more worried we should be. But instead, he put it up as an equation to make it look like, oh, we've got our scientists and they've got an equation. Everything's going to be okay. Next slide. So this mathiness is fundamental bullshit in the way that we just defined it. You're disregarding logic and factual accuracy. You're trading on this rigor that's conferred by mathematical equations, and you're doing it in order to try to impress or persuade your audience using this sort of algebraic shock and awe. And we see it everywhere, particularly in reasons I don't understand. It's very, very popular in management studies. And I don't know what to make of that. Anyway.
That's for another time. Like we said before, what we're trying to do with students is to move their attention away from the scariness of those statistical procedures and those algorithms, and really focus in on the data that was used to make those decisions and conclusions, and also the interpretation of that data. It doesn't mean we never look into that black box, but so much of the time that I spend reviewing papers and reviewing proposals, the time that the most of the mistakes I find are in the time that I spend focusing in on that data. And it's especially important nowadays, since so much of our world is being governed by algorithms that are trained on data. So just like humans that can be misled by data, which is sort of the core theme of everything that we do in our teaching of calling bullshit, machines themselves also can be misled. And so we want to teach the public how to be able to call BS on machines as well, and the algorithms that drive them. So we have another kind of classic example. Many of you probably have seen this, and if you've read our book, you certainly have seen this. This is one of our classic case studies. So I'm going to go through it pretty quickly, but I just want to demonstrate how you can go through a paper like this. You can call BS on the results by not even talking about the algorithms. You'll notice here that I won't say a thing about the algorithms they use, because you don't need to talk about the algorithms if you just focus in on the data that was used and the data that they used for their interpretation. So this example, this paper, when it came out, Carl and I and many others around the world saw this and called it out fairly quickly. That was one of those advantages of social media at the time, is that we could, and hopefully we can continue to do this, is that we see something really fundamentally wrong with trying to be able to automate the inference of criminality using facial images. And so this sort of takes us back to George Orwell and the Minority Report, where you have these intrinsic qualities you just simply can't get rid of. And this roots back to the late 1800s, when Cesare Lombroso who wrote in The Criminal Man, and also one of the sort of originators of the field of criminology. He ended his career, unfortunately, thinking that you could look at the morphological features of an individual's face and be able to say something about their criminal disposition, their sort of the probability that they would be eventually that criminal that we need to put in prison. So if you looked at this paper, they didn't give a lot of images, and they gave some details about where they got their data, but they essentially were grabbing data from two different sources. One of the data sets were these sort of government IDs, kind of like, you know, these driver's license that we have in any country, and then also are these professional or professional websites like LinkedIn, where we advertise ourselves to get that next job and to network with our community and in business and other fields as well. So
and
if you
critically, the criminal IDs were from the criminal faces were from government IDs, and the non-criminal faces were from the networking site.
Right, that's kind of the key point. So as you can see by just that description right there, you know exactly where this is going. But what's interesting in the paper, you see this kind of text, and you see this in papers like this all the time. Unlike a human examiner, a computer vision algorithm has absolutely no subjective baggages, no emotions, they don't get tired, et cetera, et cetera, et cetera. And of course, this is bullshit. And you see that, and you know, I'll skip that since we're trying to go through pretty quickly. But what you find in their results section of their paper are the key features of these faces that seem to discriminate between the criminals and the non-criminals. If you look at the image on the right in B, you see there's this angle between the nose and the mouth. Rho and theta here are the discriminators. And if you looked at it for just 2 seconds, you see that the real discriminator is that they're essentially smiling. So they'd come up with an algorithm that was able to distinguish people that were smiling and not smiling, which is impressive. Not so impressive now in this time when it was done. I think it was 2016 or sometime around that. But certainly would have been impressive in the early 2000s to have come up with a smile detector, but certainly not a detector that could tell whether someone's a criminal or not. But this thing spread virally, and this keeps happening again and again and again. Carl and I call this sort of phrenology 2.0, and we saw this in what was called the Gaydar paper from a group of researchers at Stanford that essentially claimed that they could use computer vision to tell whether someone was gay or not from looking at their photos. And
what it really did was it checked to see whether you were wearing a baseball hat in your dating photo.
Right, essentially,
because
that's what
gay men have better style than that.
Right, and we can sort of, you know, clearly knock these kinds of papers down for problems like this and their methodology. But what's sad is that these can have the implications of these kinds of papers can be quite negative, especially in places that might want to use these technologies to try to detect whether someone is gay or not, and you can imagine all the other ways in which this could be highly problematic. So you noticed in that particular paper, and we went through it, of course, very fast, and I know we have an audience that can pick those things up pretty quickly, but I just wanted to note that I never mentioned which algorithms they used to do such a thing. We were only talking about the training data that was coming in, training data that was splitting the criminal faces from the non-criminal faces and the discriminator between those two. And this happens again and again and again. And these are the kind of habits that we want to create with our students and the public when they hear these kinds of claims that really sound too bad to be true or too good to be true. All right, so let's move on to selection bias, which is one of our favorite topics, and it's one in which you can focus in mostly on the input data, and it gives you that power to call BS on the data. So selection bias occurs when people that you sample or whatever you're sampling differ systematically from the population at large with respect to the question you're asking. So let's look at some examples. So this is something we hear in our radio, in our radio stations, on our TV all the time. Insurance companies dominate our advertising world here in the United States, and probably maybe in other places, although insurance runs differently in different countries. But it's probably one of the things you hear more than anything on commercials. But there's a puzzle with the insurance industry, and that is if you look through all the different advertisements that you see online or in the news, you see that you seem to save about $500. So if you look at Progressive, switching saves you $500 on average. If you look at Allstate, you save $498. If you look at New Farmers, you save $502. Look how small the difference is. With Geico, it's $500. And what explains this, convergence around $500? Now,
how can everyone be $500 cheaper than everybody else, right? That's the puzzle.
Right, that's the puzzle. And so if we were in class, we could, then discuss. If we're all in person, we could raise hands. But I think many of you probably see this, that essentially this is a selection bias problem where they're only looking, again, assuming that this is actually accurate. These are accurate numbers that they're reporting. But if they are accurate numbers, then what it's really saying is that this is the selection bias part is that it's only looking at those that are making the switch. So if you only look at those that are make the switch, essentially what this number tells you is that's about what it takes on average to get people to take their all of their insurance that they might have, their car insurance, the auto insurance, everything, and then move it to a completely different agent and a different company.
The way I think these ads should be phrased is switch to Geico. It's about a $500 pain in the ass.
Right, exactly. And that's exactly what's going on. And it's, I would say, more so than that. Another example that occurred during the pandemic, and this was something that Carl pointed out, and then I ended up looking in our data and found that this actually went, to no surprise, I guess, afterwards, that this went viral. This was a claim during the early parts of the pandemic that dentists were seeing a higher relative percentage of people with really severe dental caries issues versus just the regular checkup individuals. And they were claiming that the explanation to that was that people were wearing masks, and that they called it mask mouth, or at least that might be how it was described in this Washington Examiner article, where, I think their explanation, depending on which posts you were looking at, were that maybe you were not getting enough oxygen. Of course, none of this is true. I'm just sort of claiming or explaining what they were claiming at the time. And this, again, is another example of selection bias. Who's going to go to the dentist in the early parts of the pandemic when everything's closed to just do a regular checkup? But you certainly would have individuals going in if they couldn't eat, they couldn't sleep, it was so painful, they couldn't think. And so, yes, the dentists at the time were probably seeing a higher relative number of severe dental issues post-pandemic than they were pre-pandemic. But this was a selection bias issue, and that they were only seeing those individuals that were coming in because they had to, versus the sort of regular sample that you get from the population. So this is another example.
This particular one was based on a sample study that was done in, so they were comparing New York City in January of 2020 against New York City in April of 2020. So in January of 2020, everything was normal. In April of 2020, New York City was one of the scarier places on the planet to be. And almost the entire city was shut down. The levels were really high there. Death rates were really high there. And so people were, of course, postponing ordinary dental care. So that's where that's going.
Well, and actually, selection bias comes in many different forms. And that's why we devoted a whole chapter, could devote far more to that. And one of our favorite examples that we have in one of our case studies is based on an article that started in The Conversation. Many of you know that. A Conversation is a venue for academics generally to write about results in a form that speaks more to the public and can get out quicker than a research paper. And then those things get picked up by other parts of the media. In this case, this article about the effects, according to this article, of sort of going into different kinds of music genres on people's likelihood of dying early, got picked up by the Washington Post. And if you read the article, this is straight from the article, that murders in this paper that we're going to talk about in just a second here accounted for 6% of deaths across the sample, blah, blah, blah. The main thing I want you to read is that we don't lose half the battle. So it's basically saying that this is more dangerous and more hazardous and more occupational hazard than war. We don't lose half our army in a battle. So let's look at the data they were basing these kinds of conclusions on. So if you looked at this here, what you're looking at is the average age of death, and then you have each one of these different music genres on the bottom. And one of the things that we tell our students all the time is if you see a drop that looks like this, if something sounds too bad to be true, it generally is. Not always, but generally is. And in this case, to see a drop like this across the different music genres, says that either really this is as dangerous as what they're saying, that you should never have your kids ever play punk or metal or rap, or maybe there's something wrong with the data. And I think the alternative there is probably the latter part of that explanation probably makes more sense, because you can look here, U.S. female life expectancy, U.S. male life expectancy, and you see this massive drop off. So what could potentially explain this massive drop off? And this is something that is a form of selection bias. It's something called right censoring. There's also left censoring. But it's not that rap or hip hop stars are more likely to die. It's that they haven't had time to die yet, mainly because these music genres here are ordered in sort of the age of that particular genre. So blues have been around much, much longer than something like metal. So someone who decided to be in a band, a metal band or a rap group, haven't had the chance to die at the age of 80 or 90, most of them. And so this is likely going to, you're likely going to get this sort of drop off just because the more recent music genres are much younger, and the individuals that play in those bands didn't get a chance to die old. So that's an example of selection bias and the kinds of things that we try to teach students to look out for. And there's lots and lots of different kinds of selection bias. But let's move on to causation and correlation. So one of the most 50 shared research studies about health outcomes that was published in PLOS found this pretty interesting result. They found that a third of all journal articles misattributed causality based on correlative evidence. That's the researchers themselves. And because of that, likely, many of them were misattributed in the news articles that were written afterwards. So half of the news articles were misattributed causation or correlation for causation. But even worse is that a third of them were done by the researchers themselves. And these are the 50 most most shared outcomes. And so that's really says that this is hard even for the researchers and for the journalists. So no wonder the public also has challenges when it comes to this sort of thing. So another thing that went really quite viral. This is one that Carl and I share in the class, and I think it really speaks to first of all why some of these things go viral, but why we need to teach causation to students in more of our classes and earlier on in students' education. So this one was a claim about bald men and that they seem to be at higher risk of severe coronavirus symptoms. This was talked about in many different news media. Forbes here reported on this. This was actually translated into lots of different languages. It was another one of these that we can track because of the data we collect. And this goes viral because everyone's concerned about their self if they're bald, or their friends or family or neighbors, that maybe they're more at higher risk. And the two variables that we're looking at is baldness and COVID risk. And this little dotted line we write to indicate a potential association. And there very well might be an association.
There was. I mean, they found a strong association. Mm-hmm.
Yeah, exactly.
And then they had a hypothesis. Yeah.
Right. And they had this hypothesis here. And this was the hypothesis that they came from, that there was this endocrine involvement that was leading to COVID pathogenesis. And it came from a legitimate paper. If you look at this paper and journal, the journal itself, the Journal American Academy of Dermatology, it's not a predatory journal. So a lot of times we find these kinds of examples, and they're in very low tier journals and even predatory journals. This is not an unknown journal. It's a good journal. And if you look at the paper, they have a pretty sophisticated figure 2, that explains what could be possible targets of this androgen pathway for COVID. And you could be convinced of that if you even look to the source, because we tell our students a lot of times to go to the source. And that's one of the big reasons we talk a lot about science, is because if we're going to get better at debunking misinformation and bullshit out there, we need to go as close to the source as we can. But even when you go to the source, especially for someone that doesn't do this for a living, like a researcher or a scientist, this can be very intimidating, and it might look like it's legitimate. So you look at this paper, it was published in this place. Okay, maybe I'm more susceptible now because I'm a bald person or something. So, to cut to the chase, it turns out there was something missing in their explanation. A common cause of both baldness and COVID risk is age. And so this is one of those examples where we really try to encourage the students and the public that we talk to about this to think of alternate explanations and common causes that could make those two variables that do have a strong association both go up or both go down. And in this case, it was so obvious that Forbes had to do a retraction, and many people called this out. Thank goodness there are a lot of good bullshit callers out there, and we encourage that. And this is an example of what people can use to improve their skills if they weren't the ones that were calling this particular one out. And then another one here is when, anytime that AI is involved, AI, I think, seems to be magic to the public. And there's reasons to think that. I think we all have seen some of the magic that has occurred in the most recent revolution round for AI, that when we think of AI, and AI comes in, of course, many different forms. There's really kind of two big forms that people mix up. It's the sort of predictive AI and it's generative AI. And it's in the predictive AI that I think we're especially susceptible. Well, we're susceptible to the generative AI now too, and we'll talk about that if we have a chance during the discussion. But predictive AI is one in which we can be misled often if we're not focusing enough on the training data and the interpretation. So going back to that schematic, we need to be doing more of that. And Carl and I use this all the time as a way of finding our examples and to call it out when we see it. And during the COVID pandemic, there was a ton of attention around AI being able to come to the rescue, to be able to look at radiographs and be able to predict faster than a radiologist whether someone had COVID or not and what to do about it. They must be seeing something that those, well-trained medical professionals that have gone to medical school, many of them in their practice for many decades, couldn't see. But of course, the AI might be able to see it. Fortunately, there were some great papers that were able to show what these things were seeing and what they weren't seeing. So in this example, the idea here is the association between potential disease state and image features. There are image features that are associated with the disease state. And the question is, could the system learn these features that correlate with disease state and then be able to predict that someone's going to have some condition before it happens? Sort of AI to the rescue. And if disease state is causing these image features, the AI will be diagnostically valuable. And that's what a lot of startups from Silicon Valley want to be claiming. And that's something that, would get people excited, of course. And that's the thing that we want them to call, at least be skeptical of. And so with this particular example, what is it that the AI was actually looking at in this paper, and actually in many papers? There was, I would say, hundreds of papers, because there was a review that looked at all the claims of these papers and showed all the places that they went wrong and likely went wrong. It's actually, one of these papers was from some researchers at the University of Washington, which is where we're at. And essentially what they had found were features that did be able to, that sort of linked this association between disease state and image features, but it wasn't anything about the etiology of the disease. It had more to do with where the image was taken, how it was taken, whether it was supine position, whether it was in an outpatient clinic or whether it was in an emergency room. And those different features did tell you something about whether someone had severe coronavirus symptoms or were in a much more concerning state than another patient. But it was nothing about the AI being able to see something in the patterns of the inflammation of the lungs. It had everything to do with these features that had nothing to do with the actual disease. It was just something that was associated with it. So the hospital itself could tell you something about the disease stage and image features. So the system learned really to how to tell hospitals apart, and other features as well, depending on which paper and which claims were being made.
Right. So different hospitals. Yeah, go ahead. Oh, keep going. You got
yeah, go ahead.
No,
Yeah.
please.
Oh yeah, so this one you can see here, this was a portable machine. So if the patient's in such a bad condition that you had to sort of wheel the image machine over to the patient, then yes, that was an individual that was in a severe state, and some of them probably ended up dying, unfortunately. And that wasn't, again, that the AI was able to look at the sort of patterns of that particular lung and say something predictive like that. They were simply looking at other kinds of features, which could be useful in some circumstances, but it's certainly not something
Not useful to the physician. The physician knows the physician knows how sick the patient is, and they know what hospital they're in. I mean, one of the main things these systems did was every the different the different X-ray machines and the different X-ray technologies have unique sort of diagnostic feature, unique stamps essentially that they put on their on the output. And so they just learned that, the hospitals where really sick patients go, oh, these are the stamps there. So when they saw that stamp, they'd say, oh, that patient's really sick. They weren't actually looking at the lungs at all.
Exactly. So when I'm noticing the time, so we're going to wrap up here in a few minutes so we can get to discussion. But the point here is that we can call BS on the data being used for the AI and then the conclusions too. So we can do this both for the human and hopefully the human reading the machine's claims as well. And so that's what we're doing. So I'm going to just quickly go through data visualization, and then we can wrap up here. But as with statistics and mathiness and other forms of quantitative presentation, data visualization, which is our main way to communicate data, is an easy and fun place to actually call this BS out. And you see this all over the place. Here's an example from a company that sells data. It's not one that I know of has any sort of left or right leanings. But so when you see something like this, where it says over the past few years, carbon dioxide emissions worldwide had stabilized, and you see this sort of stabilization feature in this particular curve, you might be thinking, you saw it on your phone or you saw it quickly moving across your news feed on social media, you might think, maybe things are getting better. But of course, if you look closely at this particular figure, like many of these kinds of figures, you have this strange manipulation going on in the x-axis. And again, I don't think this was done nefariously, but you see it sort of in 30-year increments and then now 1-year increments, 2010, 2011, 2012. And if you were to replot this is the same exact data, but with equal axes, you get a very different impression of the data. Carl and I talk about this a lot, that you can get an impression with data presentation, especially in graphical form. And so we need to teach the public ways in which to, sort of call BS on these things. You see this in maps all the time. In this example, they use different bins and it was hard to make this comparison. Yet this image right here was being used to steer arguments in the state of Georgia during the pandemic about whether there should be lockdowns, masks, etc. And you can't do those comparisons. But in the defense of the individuals that created this, it sounds like they were using software that maximized this. So this isn't about just consumption, but it's about teaching the producers of these graphs to be on the lookout for the kinds of ways in which the automated machines that you're using and the automated software that they're using can lead to misinterpretations. And that leads to a really important principle in bullshit studies, which is never ascribe to malice what can be adequately explained by competence, and even better than that, never ascribe to incompetence what could be understandable mistake. This is something called Hanlon's rager. I'm going to skip some of these examples. They're essentially, if you want to make something look vastly different, of course, don't, especially with bar graphs, don't include the zero axis, because this is the same graph here. You'd get a very, very different result. I'm going to skip these. These take a little bit longer to, and if you want to use, if you want to make something look like there's massive growth, use a cumulative plot like Tim Cook and many people from different White Houses have when looking, making claims about the number of coronavirus tests. Just use a cumulative plot and it looks like you have explosive growth. Watch out for that, because it might not, the one that they probably should put, the non-cumulative form, the sort of quarterly sales here would have been a much different stories. So designers have this great latitude to determine how you feel about the data, and we want people to be on the lookout for that. So now just for the last little bit here, and I think we'll maybe skip a few things and we can go back to it if you want to, that I think we sort of give machines they sort of a confidence that's sometimes many times undeserved. We already talked about the sort of overconfidence, at least of people thinking that machines have certain abilities when they don't. We've been spending a lot of time creating games and different education resources trying to prepare the public for these new technologies that we've seen. So we put out this game called whichfaceisreal.com, which was essentially a game to bring public awareness to deepfakes at that time. So these StyleGAN images that sort of have led to a lot of the different things that we're seeing in our new world of generative AI. And the idea here was just simply to have the game played, and it's been played tens of millions of times around the world. And we've actually, so many things that we were talking about and other people were talking about too, because of the concerns that we had with this technology being injected into our collective conversation, is that we've seen sort of the effects even in science. So I wanted to find an example that was just a relatively recent example that shows that even scientists, so we think we're, in this special privileged place of being able to pay attention and find these things. But there's a scientist in Missouri, his name's Mark Johnson, and he's done some really great work around wastewater, especially as it relates to the detection of infectious diseases. And he talked about a story that recently happened to him just a few days ago, where he had got a message from this individual, Julia Allen, who appeared to be a PhD candidate at Cornell University. And the message that he originally got was, "Hi, Professor Mark, has your research on the impact of COVID-19 on the human gastrointestinal tract come to a conclusion?" And like any interested scientists, we love it when people reach out and ask us about things that we have expertise in. And so she started talking back and forth, but then decided something just didn't sound right. Although academics don't sound right a lot of times anyway. They're a little odd. And so it's hard to say whether they're real or not. So as he started to look into this individual, Julia Allen, he soon found that the papers were legitimate, but they were by another individual. The places that the repository had been placed seemed there was some odd things about the repository, the papers, et cetera, et cetera. So I won't go through the whole story that he has told, but long story short, this individual was not real, and it was generated through Gen AI, the image and the content and everything. But here's the interesting part about this example, and this is why I wanted to show this example. One, it did sort of trick Mark Johnson, and when he did his initial checks, he found that this individual was a paid user. So why would someone behind the creation of this fake account, this fake scientist, even pay? That sort of is one of those big check marks. We say, well, are they a paid user? Okay, then they're probably a real user. But all these checks had passed initially, which is why he was engaging with Julia Allen, which is not a real person. But the point here is that with these new technologies, both the written form, the visual form, the audio form, all these different modalities that people are using now can even trick those that are supposedly, on top of these things in their own field too. So we have to be on the lookout for this sort of thing at all stages. That's the main point.
What was the aim, Jevin?
That's what we couldn't figure out. I couldn't figure out. He couldn't figure out. Mark was talking. He couldn't figure it out. That's the thing. Like, what is the aim?
Wild.
That's what we have as a challenge for us nowadays, is to be
Wild.
for this kind of
I
stuff.
know this story. Yeah.
Yeah. And so we have to be on the lookout. And so Carl and I wrote a paper a couple of years ago about how misinformation in science and about science is something that we can't ignore. We, of course, study these issues a lot of times in the political context and in crisis context. But we do need to look at it in science itself. And science is susceptible to hype. Science is susceptible to things like the predatory market. Science is certainly susceptible to these massive changes going on because of generative AI and other forms of AI. We have to be aware of this too. And whether it's citation bias, filter bubbles, all these kinds of things that we talk about in the more in the social or the society sense, we do also need to address this in the science. And I'll just give one example here that really speaks to the subtle things that we are doing and don't do. So as we all know, the opioid pandemic has been really a massive, massive problem in the United States and around the world. And historians and STS scholars who have looked at this have put sort of point a finger a little bit at science itself and medicine itself. And there are certain papers that have received way more attention than they ever deserved. In fact, they become so bad that like the New England Journal of Medicine put this little note that you would miss if you were just sort of quickly finding where that website was, downloading the paper, and then moving on to your next task. You might have missed this note that says, for reason of public health, readers should be aware that this letter has been heavily and uncritically cited as evidence that addiction is rare with opioid therapy. So this was cited and continues to be cited as support for some of the behavior and policies that were driving potentially a lot of this serious problem that we're having. But here's the thing, like, don't we have better mechanisms for slowing this down than some little blue box here that says, well, watch out, you know, be careful of what this is saying. We need to do better in terms of how we present these. And this is just some evidence that shows how it continues to be cited. And this has got historical context. I remember when Carl and I were talking about, wow, look, you know, with GPT-3, look at all the things that it can do. There were demonstrations and there was excitement. And then, of course, we're well beyond GPT-3 and what it can do. And now it's, you know, stealing $25 million. This kind of technology is stealing, you know, massive amounts of money using deepfakes from chief financial officers. And they still haven't recovered this particular example, but it's affecting regular individuals in society as well. So this, like, calling BS has implications not just for being, you know, responsible citizens of our information environments, but to not get our money stolen from us. This is getting worse and worse of a problem. So this is why we really have to pay attention. And we've been a part of some bills that have been written in our state of Washington. And actually, we've been talking with Finland, your neighbor there, about different kinds of policies and education interventions around this, talking about the ways that how search being mixed with generative AI is leading us into a really problematic period as we sort of transition into this new arena of generative AI. I won't go into detail about this, and if we have time, I'll talk about this paper here that's this overconfidence of what these technologies can do. And the point is that they actually are quite brittle. Even today, even the most advanced forms are brittle, and Carl and I are writing a bunch about this right now. And so I just say that, you know, machines, they have this confidence and certainly this overconfidence in doing that. So I'm just going to stop there and go to the very last slide, because Carl and I, as always, have a lot of content here. So I'll just end with the sort of take-home message here, which is, I'm coming back here, having to share again, that, oops, sorry, share. Why is it not sharing it? Okay, sorry, there. I got to get to this slide because we've been talking fast here. Okay, here we go. Share one more time. Share. Share. There we go. All right, we need to question numbers. As rarely we question words. Technical expertise is often unnecessary. We want to use this black box schema that we kept coming back to. Of course, this is only a sample of the kinds of things that we talk about, and we even get extra time talking with all of you. Usually we only get like 45 minutes, but we want to be aware of things like correlation causation, selection bias, misleading data viz. And machine learning certainly is powerful. I teach classes in this. Carl and I talk about it all the time, but overconfidence is too common, and we need to prepare ourselves both in science and in society for this overconfidence that can mislead us in many of the things that we do. So with that, we'll end and we'll open it up to discussion. Thanks for allowing us to chat away about different things that we care deeply about.
Yes, thank you.
Thank you very much. This is awesome. If there's questions from the audience, please raise your hand, either in the room or online. We have about, I don't know, you have to leave early, right?
Yeah, if we say maybe, what do you think, Carl, 20 minutes or so?
Yeah, let's do 20 minutes of discussion and then we can get to class. We can still get to class if we do that.
Yeah.
Okay. Okay, very, very cool. So as there's no hand up, let me, you go ahead, go ahead. Okay, Mike Tom, I just didn't see your hand. Okay, go ahead.
Okay, can you hear me? Or should we do something with the sound?
You need to come here, I think.
Thank you for coming up to the mic.
Yeah. Basically, what I wanted to say that number one, it is super cool, and I really think that it is probably sort of the most important thing to do now in teaching to
Thank you.
Sort of spread this culture of questioning, sort of actively questioning the data we see, and this. I'm happy to say that we are doing a little bit of that, have been doing a little bit of that without knowing about your course, and now
you got a textbook.
Yeah, and now we got a textbook, and that's great. Yes, and but another thing I wanted probably, I had sort of many ideas while listening to you. Probably to be brief, I will mention two things. one, what worries me a lot is that sometimes, well, my example will be about methiness, as you call it. Sometimes sort of the proper scientific side of things is behaving as copying bullshitters. And that is worrying me, to be honestly, a lot. For example, the thing I was thinking about is for the last several years in Paris, I think in Gare du Nord metro station, the whole station is covered by frankly rather ridiculously looking formula, which are supposedly representing the science of climate change. They look bizarre to a scientist eye. They definitely look like an ornament for general public who is seeing them, and it is sort of to myself and to many people, I think you read it as if climate science was as bullshit as basically your management book style.
Yes, yeah, right.
Formulas. That was one thing I wanted to mention, and another one I wanted to throw in this question. Basically, it looks to me like there are sort of going back to the very first part to humans as information foragers and the environment changing and they not being adapt to it. That we have, it seems to me that we have big problems every time we change the way information is transmitted.
Yes.
So if we go back in time, then we had a point in time when basically radio came in and sort of information in unwritten form was started to transmit, and it was like 20s, 30s of the last century. And before that, we had a point when there was this printing press invented, and it sort of
absolutely. In fact, in Plato's Phaedrus, Plato explains that it's that the development of writing is a bad thing because it weakens people's ability to think, because they're offloading their cognition onto a physical artifact instead of holding it in their heads.
Yeah, but also it allows you to make sort of meticulous.
And Plato's wrong, but it's just, I mean, people have been complaining about this forever.
It looks like writing probably was the thing which started sort of the authoritarian city states of Middle East or something like that.
Yeah, right. That's right.
Okay.
Yeah, thank you very much. I think we should also like summarize a bunch of points which have become really salient in the last couple of weeks, days, as something that sort of like is really overlooked. Like you, in your last slide, you said technical expertise is often unnecessary, and you brought this example. The same can be said for misogyny, for homophobia, transphobia, xenophobia, greed. All these things can be easily spotted. You don't need science to actually see that, right? And so that is sort of something which is quite weird, because the people who sort of fall for that at the same time have something that you also promote, which is this first thing, questioning numbers. I mean, that's the whole spiel of Robert Kennedy, right? It's sort of also the spiel of Elon Musk, saying basically we don't need all these engineers in NASA. We can basically fly to Mars with a bunch of welders who are good in doing grain elevators. And so obviously, you know, the grain elevator only flies because there were a bunch of scientists who are really good in differential equations. And so that is sort of something which I think is a really difficult thing. But at the same time, there's two things you didn't mention, which I think, which is not a critique, but I think it would be interesting sort of to bring it into this sort of discussion. One is, based on your observation, you say what's exploited is actually not individuals, it's the behavior of individuals. So actually, you know, people don't exploit oil out of the ground. But and it's also not data. If you own the data, you don't basically have anything. What you need to have is an understanding of that data. You need to understand how it functions. And that actually means you need the traces of people in order to sort of like, not the people themselves, but the traces of people in order to anticipate these traces. And that is a really interesting thing, because I think what is a little under-researched, like we always think about, like, how many papers, how many talks have you seen since 2012 about misinformation in the internet and how it actually reaches the audience and how you sort of like, you do fact check and whatever, but nobody seems to look, relatively speaking, to what the actual purpose of the exploitation is.
Yeah.
It's not to misinform people. It's to say, oh, okay, so I induce bullshit because then I can predict when the system is destabilized, and I can make money on that because I have absolutely no fucking clue how to predict the system, how it behaves in reality if I don't induce bullshit. And that is really interesting, because if you look at like the people who sort of are behind the bullshit inducing, it's the same people who tried really, really hard for a couple of decades actually to predict society.
Yes.
Right? Like Bob Mercer's thing with Renaissance technology is exactly that.
That's
in how to
fascinating.
use the bullshit. So that is sort of something which we have completely overlooked as a community. We all look at like, oh, how can I actually sway the voter and actually not fall for bullshit? While there's a completely different ballgame going on in the background where people couldn't care less about the individual users. That's the difference between us and the people who are greedy and exploit, because they seriously don't care about the voter. That is a pretty crazy notion. And I think there may be, just as you have sort of shown angles how to get to people, different angles if we actually surface that. We say, look, it's really easy to spot xenophobia or if the guy's misogynic. It's really, really easy. You don't need any science. But in the same way, we really have to look what is actually going on and why this kind of exploitation and why the bullshit happens. And that is sort of something which is completely under-researched if I'm not ill-informed. Maybe
that is fascinating. That's really interesting. And I think about, Dogecoin or whatever, and absolutely, right? And it is also completely true that it is right. Figuring out what markets do when people are not misinformed turned out to be too hard. It was easier to just misinform them and then exploit the markets. And I hadn't seen that before. And that's a very powerful point that you make. You also, I just wanted to address the sort of RFK, do your own research kind of thing, because we didn't talk about that here, but this has really become a really important part of our teaching. I was part of a Moore Foundation funded project during COVID, actually, where a bunch of us met for a couple of years to try to figure out how to re-envision the science curriculum for a post-truth era, right? For a internet bullshit era, and absolutely this rhetoric of like, do your own research, figure it out for yourself, is very commonly used by crackpots, skeptics, scammers, etc. And so part of the reason we're vulnerable to that is because we do a very poor job, at least in the United States, of teaching people why science actually is reliable. So if you ask, if you look at the curriculum, if you look at our curricular standards, if you ask high school teachers, if you ask a lot of faculty, you say, why is science trustworthy? And they'll say, oh, well, because people do experiments and then they they generate a hypothesis and they do an experiment and then they confront the data with the experiment and then they reject the hypothesis. And they give you this little, sort of folk Popperian caricature that actually doesn't really have a lot to do with what we're really doing. And what they will not give you an answer, and what our teaching doesn't address, is the actual entire social process of science, and the way that science is this social enterprise with a set of institutions and incentives that make it extremely reliable. Why is, so just to sort of start out, you think, well, you know, I ask sometimes when I lecture about this, I say, you know, how many people here believe in anthropogenic climate change? And almost everybody raises their hand. And I say, well, how many people have read the IPCC report? And a handful raise their hand. And then how many of you are qualified to actually judge it? And then maybe one person raises their hand. And I said, well, why do you all believe in the IPCC report then, like in climate change? And the answer is because we know how science works. We understand what the incentives are. We know what authority is. We know who are the authorities. We know we know what expertise is, and we know that when you have something, you know, a very strong consensus among experts, that this is a very highly reliable result. So you get Kennedy saying things like, Fauci bought Omerta, you know, basically paid off the world's virologists with grant money to not tell the truth about to not tell the truth about the COVID vaccine. If you know anything at all about science, you know why this is so goddamn stupid. Because if, you know, first of all, Fauci's only funding US scientists. Second of all, nobody gives a shit about Fauci's funding if they have a Nobel Prize that they can get without it. Right. I mean, so if there's like, you know, if it turns out that like that COVID is actually a consequence of some vaccine that he's claiming it is or whatever, you know, whoever discovers that is going to be tremendously. And so once you understand how these social institutions work, you realize that all of these sort of, you know, authoritarian stories of hierarchical top-down control and secrets, and none of this makes any sense. And when you understand what expertise is, and we understand how scientific consensuses are made, and you understand what the incentives are to challenge these consensuses, then you can see why, when you have a situation where, you know, 99% of the you know, people that are considered qualified in climate change support anthropogenic, you know, explanations for climate change, you see why that's so powerful, even if you don't know the math yourself and haven't read the literature. But we never explain this to our students. And this makes them very, very vulnerable to these, you know, well, do your own research. And then they just think, well, I read a little bit of bullshit. And it's like, well, it's like, no, doing your own research actually mostly involves, in science, the world's too big and too complicated for anyone to understand how everything works. There's no person on the planet who understands everything that goes into a Boeing 747. You know, there are people that understand the flight engineering, there are people that understand the computer systems, there are people that understand the manufacture of the silicon chips. Nobody knows all of that, but we know that those systems work, and that's how science is as well. And so you can't just do your own research any more than you can just do your own repairs from the ground up on a 747. You have to understand the way it's situated in this social matrix.
And I'll just, so just to add on to that and add on to what you had said, Max, which I also agree is super interesting. And it's got
fascinating, yeah.
It's got me thinking in already a bunch of different ways.
Me too.
We should chat more about this, but I'll just mention two things. So one, there's a huge literature all the way back to the Cold War that talks about the strategies that you would use to you know, inject disinformation and what you get from doing that sort of thing. And so I did a little research seminar class a couple of years ago on global disinformation. It was fun digging into that literature. Not fun actually reading some of these sort of strategies, but the goals behind it sort of might, you know, we could go into a little more detail about what you had said. The second thing I want to just say is that there's, as a continued critique of all these papers and presentations that you had mentioned, that we've all heard about why we're falling prey to misinformation, what do we do about it? Most of the focus is around these high-profile papers in Nature and Science that look at really circumscribed data sets. So a lot of them, for example, will look at the articles that have been fact-checked by Politico and Snopes and other kinds of fact-checking organizations, and then use that as the unit of analysis to make claims about whether misinformation is a problem, whether it's not, whether it's getting worse, whether it's getting better. And it's a real confined and actually misleading, I think, view of what's happening when it comes to misinformation. I think what's much more of an issue are the kinds of things that aren't at the individual article level, not at the individual headline level, not the individual even bad science paper. These are typically these sort of broader narratives and frames that are created, sometimes intentionally and sometimes unintentionally, where you sort of give the audience the frame
to then go look for the evidence yourself. So you say, for example, stop the steal sort of thing. And then everyone sort of goes out there and looks at evidence. And sometimes there's some evidence that you might find, but just sort of fills that frame. And you would never detect that sort of thing if all you're looking at is an article that was debunked by a fact checker. I mean, this is an oversimplification of the field, but I think it's a real problem because you can't detect it in those kinds of ways. And also, I think one of the problems when we look at misinformation as a sort of a field, I think it's really difficult to get away from one of the big attacks on misinformation, which is like, oh, you like researchers and scholars, you can't study that like sort of thing. What gives you the position to tell us what's true or not? Instead, as scholars, I think we should be focusing more on sort of these other large-scale collective dynamics of disagreement. So here you can then make at least claims about how close a particular claim aligns with like scientific consensus, for example. And that would be a sort of a way that you could at least study it in a way that removes you from the decision-making of whether something is true or not. But the main thing here is that these you can be misled. Here's the main point for the individual, though, and this is something that we need to put into our lessons more often, that as an individual, the most, I think, concerning kind of misinformation is the stuff that actually has a lot of truth to it, that has elements of truth and is just either misinterpreted, misframed, it's cherry-picked. I mean, you can be misled by even correct information as much as you can sometimes by false information. And so that sort of gets us back to the individual, though. But I think this broader question that you asked about, what are some of the motivations behind sort of the behavior we're seeing at that population level that really it has nothing to do with and really doesn't care at all about the individual, just cares about sort of what you can gain, the sort of arbitrage opportunity when you're sort of disrupting a system. And I think that's pretty interesting.
Super. I have one other question, which I hope you can still answer, which has to do with this notion of mathiness. So I personally am notoriously bad with notation, like both in mathematical equations and in music. But I love both listening to and doing music, and I love doing science. And so whenever I encounter something that is sort of like a wall of math, I try to visualize it for me. And because I think geometrically, that's like sort of my main motivation. And one of the interesting things in this is this has been rather successful, right? And my favorite example is the wall of math or algebra or symbolic notation of Couturat's Algebra of Logic, which is just a bunch of symbols, like sort of like, a whole book full of symbols. And then Shannon reads this, is young, writes his master thesis, comes up with the switching circuits, and that's, lo and behold, we have computers, and now we have billions of those in these little devices, which is pretty crazy. And these switching circuits were literally drawings. And he basically translated whatever Couturat wrote in symbols. And in a similar way, whenever, like last week, Zoltan Toroczkai, for example, published some kind of theorems, he does this kind of math of, the satisfiability of some kind of abstract math that's important for complexity science or something like that. So it is like, even for most mathematicians, too hard. But you look at these equations, and it's like, oh, this, the abstract is really amazing. Like, can this be visualized? And so that is sort of something which, even if you ask them, for them, this is hard too. And so that is sort of something that is necessary and is, again, something that's functional, like your traces of people, and not just substantial. So it's not the equation that gives you sort of the evidence, but if you're able to visualize what's going on, and obviously there's all the fallacies of projection and dimension reduction, whatever, in there, but that is sort of like a key thing. And that results in something that we do with our students, like everybody does, is guilty of that. Every student uses ChatGPT for whatever, I guess. So the question is how to shepherd students to not misuse it. And one way to do it is like coding with ChatGPT is way more reliable than generating text with ChatGPT, because if you take the piece of code, you throw it into Google Colab, it either runs or not. And then, if this thing produces sort of like a heat map out of a matrix, you can actually look at it and see if it makes sense and so on. So there is this functional feedback loop, which for all the other generated stuff we don't have. which we don't have for the misinformation or the information we presented with in the web. So the question is, how can we alleviate that situation and create more such feedback loops, which, you know, in a village circumstance would be, you know, if somebody tells you something and they told you bullshit the last 50 times, then you don't believe them anymore. And so that is sort of something that in the bigger scheme, we have a harder time doing. So does that mean we will only use generation for stuff like coding that you can then check? Or does it mean that we need to generate other kinds of feedback loops in this kind of way?
Yeah, I mean, I think that is one of the key things when it comes to these new generative AI technologies. And so one of the questions that I ask students is, how do you know if you understand something well? And they said, well, I think about it, I know about it. And you can come up with various heuristics, you can come up with various various evaluation for an individual human. And you could say, well, I could, in your example, I could throw some code into something and see if it gets back. And that's why that's a good example. With writing and other conceptual issues, those are a little more difficult. Well, one thing you could do is you could ask your colleagues or try to explain to your colleagues that might know that particular topic, maybe an expert, explain to them. And then what I'm trying to do is I lead them into try to seeing how writing is a form of thinking. And by, you know, you can certainly do iterative things with ChatGPT to improve your writing, to certainly improve your code writing. And I think I think what we can do for our students, at least what I'm trying to do, what's somewhat successful, maybe I'm not, maybe I'm being misled by thinking the nodding of students' heads is them actually thinking that they understand something about this. But I'm trying to get them to understand that you can use these tools, but you need to find exactly what you're saying, Max, a way of getting feedback. And writing is a way of getting feedback from your brain that you think you might understand something to not. And when it comes to visualization, which I think is the key thing, I think some of these most famous visualizations in biology, for example, Sewell writes adaptive landscape. There was nothing completely rigorous mathematically about that, and Carl can talk about this way better than I can. But that was a way to at least communicate and get feedback. And it certainly, I don't think, was leaning on the air of precision of math, but through these kinds of communicative mediums, maybe, you know, we can find ways to sort of do that with sort of this new form of AI. I'm not sure about that particular one because I think visualization is something that's very hard for these systems to pick out. But I think my quick response to your question about how do we teach the world, or how do we teach ourselves how to use this technology, I think we need exactly that. We need to find ways of getting feedback. If you don't have that feedback, if you're just thinking in your head and you think you've understood something, then you don't get that feedback. And that's what we get from science, and something I'm trying to communicate to students, but still struggling with it like a lot of us are. Carl, I don't know if you had any thoughts.
There's a lot there, and I mean, I can't possibly touch on it. So instead, there's something that seems relevant to me, but you'll have to fill in some of the pieces for me, which is there's quite a substantial literature in the philosophy of science about the nature of explanation and what constitutes a scientific explanation, what constitutes scientific understanding. And one thread of that literature is an argument that you have a theory. The theory provides understanding of a scientific phenomenon when it allows you to predict without calculating. Mm-hmm. And so, which this is often used as an attack on quantum theory, right? Saying that it doesn't provide any understanding at all. But the idea is that if useful theories break down the world into salient components with understandable interactions, so that you can think about a system and make at least qualitative predictions about comparative statics and things like that without having to calculate. And once someone has done that, they have contributed to an understanding. That theory has contributed to an understanding of a phenomenon. And I think when we think about these machines, it's quite useful to think about when our interactions with them contribute to understanding and when they don't. So, a machine that can simply generate a persuasive looking text output, but doesn't increase our ability to at least approximate this without the help of the machine isn't really contributing to understanding. It's just producing output that may seem compelling to other people, or make them think you know what's going on or whatever. So somehow asking ourselves questions like this, it's only a partially formed thought, but I wanted to put it out there because I thought that was I think it's really useful in trying to I want to try to understand how we can use these machines in ways that do enhance our ability to creatively understand the world. And anyway, so I mean, we could talk for hours about this. We should sometime.
Yeah, and we should. And I just wanted to comment to Peter's comment. So we do have a chance, because this is a really, really important point. And I think the point that you're making is that there are small bits of truth in a lot of these propaganda techniques. And we see that in the modern form online, and we saw it back in the 1950s, and certainly before that as well. And so what do we do to combat that? I think number one, we have to make the public aware of these techniques. And a lot of times we have examples from our own cultures and our own countries. I think it's better, I have found when talking to the public, Carl and I talk to the public all the time and find different techniques that work, when we talk about examples that are outside our everyday lives. So explaining to them how this technique is used, why it's effective, and what are the different kinds of methods that are employed to invoke a little bit of truth. Because if you study rumors like we do, so rumors can be false and true, and some of the most effective ones are the ones that have that grain of truth. Then by knowing that that is a technique, at least the public can be a little bit more aware of that. And I'll give you an example from before the pandemic that was one of these case studies that demonstrates exactly this. So there was basically a fake persona. Jenna Abrams was the individual. It was this individual. It was a sort of young teenage girl that seemed to be on top of all the cultural phenomena in the United States. She had gained this huge following on social media because she would comment on news around entertainment stars and sports stars, and then she got a bigger and bigger following. And then every once in a while, she just inject this propaganda that had nothing to do with any of those things, but she had this huge following. So it was like a bait and switch a little bit, like we see a lot of times. And the most effective bait and switch techniques usually involve bringing in with truth or bringing in with what people are talking about at the time. Turns out that particular individual was being run by Russian agents. And this was during the time when you had inauthentic accounts and authentic accounts. This was an inauthentic account, so it wasn't a real account, but it was being run by individuals. Now we have a much more challenging situation where we have actual authentic accounts, or at least seemingly authentic, with blue check marks and other things that look like real individuals, but of course are being run automatically and injecting those things of truth and not truth. So I think just my biggest response or thing that I try to do is just allow people to know that this technique exists and it's highly effective, and do that through case studies. Because you're right, this is such an important thing that people need to know about, and it's unfortunately very highly effective.
There's one hand up.
Take one quick one and then
Super quick one. I'm sorry because I'm like holding up a lot of curiosities back. First of all, very huge thank you. It was really entertaining and insightful. My question comes from the perspective of translation, because now it's like highly dominant English understanding which you're talking about. And when I see coming from India, where we have a huge population, with English is definitely not the first language of communication, and things get translated and the bullshit then gets disproportionately high. And then there is no keep in check, because what maybe to give an analogy, like the bullshit peddler is in power. So there's no one keeping them in check. So how do you address this issue? Because I think it will be a larger one with global north versus global south, which I think everyone in the world will face. And do you think that maybe international collaboration could be one easy way of bringing people from different places? But in general, how to tackle the problem of language here? Build a new vocabulary, find new analogies because for example, an example of Soviet propaganda would not work in India. Like how
Right.
do we really educate the masses, so called, and just like it's just disproportionately high, or like the disinformation is just so high that there's no way to like initiate any conversation.
Yeah, so just to give you some numbers that supports exactly what you're saying, when Facebook was pressured by the US Congress to start doing something about misinformation, they said, okay, we'll hire a bunch of fact checkers. If you look at the fact checkers, it's in the 30,000 or so. The vast majority, I mean, like, I don't know what the exact number is, but it's like 90% or more were English speaking, focused specifically on kind of English US related issues. And Facebook, as you know, and many of the products they make, like and they own WhatsApp, et cetera, Instagram and other things, they are worldwide. In fact, many of their platforms are used more in places like India than they even are in other countries around the world. And so you can just tell with their investment that we're not doing enough around these other issues. And as you probably know, since you're from India, one of the scary things that was happening early on when WhatsApp and a lot of these issues were arising, there were mob killings because of how fast these things were spreading virally. So the only thing that they could do, especially for a platform that had encryption like WhatsApp, where you couldn't even get insight as a researcher, even government officials, not even, you know, Meta at the time. Well, I don't suppose they can, given that it's encrypted like it is. They had to just change one small little affordance and design issue in WhatsApp, which is not allowing something to go beyond 250 people or whatever, and it actually shortened it. So really what that took was international collaborations across, you know, maybe organizations like what Carl's paper that Max had mentioned, where we need kind of like an IPCC type of consortia that talks about information health, just like the IPCC talks about sort of climate change and other things that can pressure these social platforms to really think about how to, you know, maybe the effects of small design changes. But most importantly, as a researcher that's biased, in what I think researchers need, we need access to that data. And I think that's one thing that governments can do. The European Union is leading on this. If we can at least get some data and be a kind of third party evaluate, at least that would be a small, tiny step towards addressing this, because I can guarantee you a lot of researchers would like to look at the effects, the differential effects happening between the North and the South, and the global North and global South. And then we could be able to answer some of those kinds of questions. But yeah, this is a serious issue, especially in areas, even in the United States, where people are coming onto the internet for the first time. They don't have any of this exposure. That's really the truly, yeah, sometimes the more susceptible people have to address. But Carl, I don't know if you want to just say anything.
No, that was great. And I think we probably got to get to class, or else we're going to really,
yeah, we better.
Thank you all so much. That was really, really fun. I'm honored. So I appreciate the chance to speak.
Great pleasure to have you. If you have to leave, you have to leave. I'm gonna do the 30-second outro.
No, dude, go ahead and do the outro. We'll hang out for the outro. And then
the one thing that what Vivek just brought up, one thing I need to bring up, all these recordings that we do of these lectures and sessions are available on the CUDAN Lab YouTube channel. And one of these talks that are very relevant is Denny Vandricic on Wikifunction, which is sort of like the function part of Wikipedia. That is actually made to translate between the languages, which obviously, as we had to discuss,
oh, perfect,
can be, if it's done automatically, a weapon, because, you know, frappuccino everywhere, proper cappuccino anywhere, while at the same time, it can also sort of maybe mitigate these kind of things. So this thing would also require what you just said, an IPCC for cultural spreading or something like that. But let's look to the future. So we have an exciting next 4 weeks, while we spent the rest of the week fearing what's happening in January. In the next 4 weeks, there will be 4 more CUDAN Open Lab keynotes to exemplify cultural data analytics. And next Monday, we're going to see Vittorio Loreto talking about inclusive and sustainable cities. Thank you very much, Jevin West and Carl Bergstrom. This was a great pleasure to have you at 6 in the morning and having guests from, oh, she's gone, from Chicago all the way to Eastern Europe is also great. Thank you very much.
Thanks, Max, and thanks everyone.
Everybody.
See you in class, Carl.
Yeah, see you in a few.